So we last time we went over implicit differentiation. So let's go ahead and review that. So a quick review on implicit differentiation. All right, so let's see here. Let's just make up an example from last time. We had something like, so take the derivative of the following. Implicitly, right? Or just say just take derivative. We don't have to say that part. Sorry. So part A, with respect to x. So this is just a quick review of what we did last time. Just made up a problem here. Well, actually, you can phrase it, rotate this a little better. 1 second. I'm gonna have a couple ABC on this guy. So same question, just ABC. Just wipe it away. All right. Of the following, we had 2x squared plus 3y squared equal to 7. So part A is with respect to x. All right, so that means you're going to do d dx of everything, right? Okay, there we go. So d dx of each type, we said if they match, then you just do the derivative rules that like we've always had. So this can be a power rule. It'll be 2 times 3, right? Subtract 1. This doesn't match. This is a y. So that will be the same rule. You bring down the 2, subtract 1, but you have to multiply by dy dx as a part of a implicit chain rule. You guys remember from last time? That's starting to look familiar.
Yes, sir.
Hoping it makes more sense this time now that you've just had some time to think about it and do some homework. Now let's do respect to y, just to see what happens, right? So I'm going to do d dy of the first term, d dy of the next term. D dy of 7. Okay, so now these don't match up. Notice that. So you're going to get the same power rule, right? -1, whatever. But then you have to multiply by the chain rule. So it's going to be dx dy now. You see how it's the same thing? It's just depends. It just changes a little bit based on the variable you're doing. that make sense? Now that these match, you're gonna just get the basic rule. 3 times 2 times y, 2 minus 1, right? Constants don't matter. Any derivative will make it 0. Doesn't matter what, with respect to what are what derivative, does not matter. So you get x squared dx dy plus 6y equal to 0. And yeah, technically we should be solving for dy dx, but right now we're just trying to refresh ourselves on how do you do implicitly. And now I'm throwing in, what if I do it with a different variable? Does part B make sense?
Yes, sir.
Okay. Let me know if something is weird. All right, so now what we're going to be doing today is this. With respect to something else entirely that's not on here. With respect to, let's say, time, which we'll call t. So we're taking derivative with respect to time. So we'd be doing d dt, right? 2x cubed plus d dt of 3y squared equal to d dt of 7. So now none of them match. So you're gonna have to do the implicit rule for both of these pieces. So you're gonna have the same power rule. You're gonna get 6x squared dx dt plus 6y dy dt equal to 0. Do you see how it's the same deal, right? Is there any questions on part C or part B?
So basically with C, you're using like the respect to X and the respect to Y and applying it to C.
Yeah, on part C, instead of using like over here, we had a Y and an X.
Right.
I didn't choose any, so basically none of them matched. Like on part A, the X matched, part B, the Y matched, but now C, there is no time variable technically. So you have to do this implicit part for both.
Okay, I see. Where before, if it was only one, you would do one and not the other.
Yeah, exactly.
Okay, gotcha. Okay, cool.
So that's what they're going to do on this homework, because these are going to be word problems. So this is going to represent the change in X over time. So this is not going to be meaningful. It's not just some random equation, right? It means something. All right, so let's move on to the lecture now for 3.6. You guys have any questions on the refresher, quick refresher? Let's start looking at the homework. So basically it's going to be the same stuff from the last section. It's just going to be applied to something. It's not just, general math anymore. Okay. Let me show you the question for number 1. We'll do number 1 and number 2 to start slow here. So assume that x and y are both differentiable functions of t and find the required values of dy dt and dx dt. So we got to take the derivative of this guy, but with respect to time t. So this is a simple equation, but we got to do the double implicit rule. So one for the y, one for this guy, for this root x. And then they tell me right here, okay, well, if x is 1 and dx dt is 2, can you solve for dy dt? But the hard part, the main part, I think, is just finding the derivative first. After that, you just plug in numbers. So let's do the hard part first. So let's see. I'm just going to shorten the question. One for 3.6. is problem 1. Problem 1 from, oh yeah, from, yeah, 3.6, sorry. Find the derivative of both sides with respect to t is basically what they're asking, even though they phrased it differently. So what you're going to do is do the derivative of both sides with respect to time of the y, derivative of this side of root x. I'm going to go ahead and change it to 1/2 power. That's the same thing, right? Because we're going to have to do a power rule anyway. The derivative of this is going to be 1 times dy dt, right? So this will be 1 times dy dt, because that's the chain rule. Derivative of this guy will be 1/2 x 1/2 minus 1 times dx dt, using my implicit rule. So that gives us dy dt equal to 1/2 x to the negative half. Okay, so at this point, we've gotten everything what they wanted. Now for part A, they say, I mean, yeah, I can make this prettier, but it looks like they want a specific number. It says find dy dt given x equal to 1. And dx dt equal to 2. So they give me, so if this was like an actual application problem, this would be the rate of change for x. This should be like some sort of position or amount. And then you'd find the rate of change of y over time. But all you got to do is plug these numbers in. So dy dt is equal to, we just found this earlier, so dy dt is equal to, this is let x be 1, so x times 1 to negative half times the dx dt be 2. There we go. 1 to any power is going to be 1. 1/2 times 2 is a 1. So this ends up being 1. Is there any questions on part A?
Can you explain that second step one more time?
Yeah, sure. Let's show our work a little bit. This is going to be 1, right? So 1 times 1/2 times 1 times 2 is 1, right?
Is that because it, like, since in the exponent it was a half, you took down the 1, you took down the 2, and that's why there's 1 and 2?
This one came from, that's what they told us x was equal to.
And then where'd the 2 come from?
That goes here. The dx dt was equal to 2.
Oh, okay, okay. Oh, okay. I see what you were saying.
Yeah, just plug them in, and then at that point you're just multiplying numbers.
Okay, the x was the 1 and the 2 was the dx over.
Excuse me. Yes. Yeah.
Okay. Gotcha.
And any other questions? See how the hard part is just finding the derivative, and then after that, you just plug in numbers. Part B says find dx dt given x equal to 64 and dy dt equal to 8. Okay, well, we have the equation from that we found earlier. Just write that again. Where's that? Yeah, 1/2 times x to the negative half times dx dt. So they gave me dy dt. So this is going to be 8. 1/2 is just chilling there. They said that this guy is 64. And now I have to solve for dx dt. So punch this into your calculator or do it by hand if you want. This is the same as saying 8 is equal to 1 over 2 times the square root of 64. So you bring the negative power to the bottom as a root, or you can leave it as a half power if you want, times dx dt. So this will become, out of space here, 1 over 2 times 8. So that's about 16, right? Multiply 16 over here. I'm going to continue writing over here. So, okay. That's a t, that's an x. So these will cancel, and giving you the answer 16 times 8. What is that? 16 times 8. Is that 128 or? Let me see. Yeah, that's what you got. Okay. This would be your answer. Anyway, do you see what we're doing, right? We had this derivative right here. Let's take it my way. We plugged in the x and we plug in the dy dt. At that point, we're just multiplying numbers. You can do this on your calculator and then divide it out if you like, or just do it like algebra style if you want. It's up to you.
The 64 went to the bottom because it was a negative square root and we wanted it to be a positive, right?
Exactly, yeah.
Okay, cool, gotcha.
So this made it go down. This means square root. Square root of 64 is 8. 8 times 2 is 16. If you plug in this into your calculator, 64, then 2 the negative half, you're going to get 1 over 8, which is what this is. All right, let's do 3. That one looks a little harder, I guess. Excuse me. You guys cool on this page? Or not yet? One moment. Number 3, so example 2. Problem 3. They say assume, I'll just go ahead and write the exact words. Assume that X and Y are both differentiable functions of t. Okay, so they give us this guy. So all you have to do is take the respective time, like I did that other example at the beginning. So they're both going to be implicit. 169 doesn't matter. So none of them match. So that's going to be 2x dx dt plus 2y dy dt. So now we can answer part A. Find dy dt given x equal to 5, y equal to 12, and dx dt equal to 5. So just plug in everything we have and solve for the dx dt. So here we go. So we have 2x dx dt that we found earlier, plus 2y dy dt equal to 0. Plug in my x, plug in my dx dt, plug in the y, and I need to solve for dy dt. I just need to isolate this guy. So 5 times 5 is 25 times 2. 2 times 12 is 24. dy dt. Subtract the 50 over. And then divide by divide by 24. So dy dt is equal to negative 50 over 24, which reduces to negative 25 over 12. Are there any questions on part A? Does the derivative make sense as well?
Can you pull it back up a little bit? Thank you.
Yeah, no worries.
And for when you did 2 times 5 times 5, it was because you plugged in the x and then you plugged in the dx over dt. And that one was 5 too, right?
Yeah, they just both happen to be 5.
Okay, cool.
Okay. So this next one, let's move on to word problems now. You guys are getting the idea of the mechanics. I'll leave part B to you guys. Okay, number 5 looks like it starts getting a little difficult. It says the radius r of a circle is increasing at a rate of 3 centimeters per minute. Find the rate of change of the area when r is 37 centimeters. Okay. Well, they want us to find an area, and they're talking about circles. So that means we need to, on our own, write down the area of a circle formula. What is the area of a circle?
Is it 1/2 pi r squared? Right?
Maybe, let's see. For example, 3. Problem 5. I think that's close.
I think it's 2 pi r squared, maybe.
Let's
Wait, I don't know.
double
Never
check.
mind.
No, you were thinking of here, let me show you guys. I mean, it's okay, you don't remember. I mean, I'm not gonna judge you. So 2 pi r, it was a formula, right? Circumference. That's the distance around. So we're gonna need some of these basic formulas from geometry. And the area of a circle was pi r squared. I think the 1/2 pi r squared might be like something from pre-cal. Area of a sector, I think. But anyway, who cares? So we're gonna need that guy. Let's see, go back to the question here. All right, so let's write down everything they told us. I'm gonna copy paste it into the chat so they keep looking at it. So they said that, so the area of a circle is this, right? They gave us the radius of 3 centimeters per. Oh, actually, they didn't give us the radius. They said radius is 37 centimeters. I'm sorry. Okay, so they want us to take a derivative of this guy. And notice they said per minute, right? They gave us a rate per minute. So we need to take a derivative with respect to time, because this is something is changing. The radius is increasing over time. So we will take a derivative of both sides with respect to time. Excuse me. Okay. So this guy's no big deal, right? That's just dA dt. We've done those quite a few times now. This guy will be 2 pi r when you bring the 2 down. Subtract 1 dr dt. Is everyone okay with this derivative? I skipped some steps this time. If that's not okay, let me know. Not a big deal. Do you see how we got here?
You put it just says dr because it was the radius, right?
Yeah, because this is the variable. So it has
Right.
to be, that's the
And
only
then-
one that we had that was not constant, because this is a number.
Right. And then the a multiplied by the dt just becomes dA dt.
Kinda, but just I mean, it looks that way, but let me show the steps just to be proper. So technically, it's supposed to be 1, right? Derivative A is 1 times the chain rule dA dt. And then over here, we get pi, and then you bring down the 2, and you get 2 minus 1 times the chain rule dr dt. Right? That's what we're supposed to do. I just didn't show that step. So this becomes 2 pi r dr dt. Okay, so we have the formula. I already forgot what the question was asking. It says find the rate of change of the area. So here is the rate of change, dA, meaning the change in area, over dt, the change in time. So basically they want us to solve for this, which is already solved for this. So great. All we have to plug in is numbers. We have r, right? Do we have dr dt?
Yes.
Yeah, they said dr dt was what? Right.
Rate of change. So it'd be 3.
Yeah, it'd be the rate of change of the radius, right? So rate of change of the radius over time is 3 centimeters per minute. So just plug it all in and we're good. So we're going to get dA dt equal to 2 pi times 37. I should write centimeters. .37 centimeters times 3 centimeters per minute. So this will become what? 2 times 3 is 6, 6 times 37, or 2 times 37 is going to be what? Let's see here. Okay. 2 times 37 times 3. Yeah, there it is. So this would be 222 centimeters times centimeters is centimeters squared per minute. Oops, I forgot my pi. 222 pi. And since it's a change in area, it should be centimeters squared. You see how it all worked out? Is there any questions on this? Because this is the whole point, is why we were doing implicit, is to solve these kinds of problems. Yeah, that's what they got, 222 pi. I'll get rid of that one. That looks hard. Okay, let's do the sphere, I guess. You guys cool on this page? Okay. Example 4, I think it was. Problem 6 from your homework. It says the radius of a sphere is increasing at a rate of 3 inches per minute. Okay, so part A says find the rate of change of the volume when R is equal to 11 inches. I don't know why I wrote it that far away, but. Whatever, who cares? Okay, so we're gonna need the formula for a sphere. It doesn't tell me what this formula is, and it doesn't tell me what exactly it should do. So let's try. I think we should use volume. Volume of a sphere. What is that formula? That one I don't remember. I'll look it up here. Oh, I see. It's 4/3. I believe it's the formula we should use. They also have surface area, which we'll write down just in case, but I don't think we'll need this. Okay. So if I take the derivative, because they tell me what, find the rate of change of volume. So that's the hint. I should use this guy. So yeah, I don't need this for sure now. So we were given what? R is 11 inches, right? And they asked about, they also told me that the rate of change of this radius is 3 inches per minute. So rate of change of the radius over time is 3 inches per minute. Okay. All right, so that's all they gave us. So now let's do the derivative. So derivative with respect to time. Derivative with respect to time. This will be 1 times dv dt equal to 4/3 times pi, bring down 3 and subtract 1 times the rule for implicit. So dv dt is equal to, so these 3's will cancel, that'll give me a 4 pi r squared dr dt. So for part A, all we have to do is plug in the 3 and plug in the 11, and we're good. So plug in r equals 11 and dr dt equal to 3 inches per minute.
Can you move the page up a little bit?
Oh, yeah, sorry. Right then, yeah, that looks like. dr dt is 3 inches per minute. So our answer will just be 4 pi times 11 squared times, got my units, 11 inches squared times 3 inches per minute. So dv dt will equal 4 times pi times 121 inches squared. And oh, I forgot again. Biscuits. Okay. Okay, so inches squared times inches gives me cubes, which is volume. That's just what, now we know we're on the right track. So I'm gonna leave it in terms of pi. Everything else will be multiplied. So 4 times 121 times 3 is 1452 inches cubed over minutes. So that's how much volume we have. I forgot to find it. Pi. There we go. Any questions on this problem for part A?
Kind of a stupid question, but how come oh, never mind. I was gonna ask how come pi was used in this application, but I like reread the question and I saw that it was using the radius of a sphere.
Yeah, that's because it's a sphere. You're right.
How did you, I'm a little confused on the 4 pi 11 inches squared, 3 inches over minutes. Part right there, you went down to 4 times pi times, what is that number right there? Is that 21 or
That is
121?
121. That's 11
Oh,
squared.
okay. I see. It was just 11 squared, right?
Yes.
Okay, that makes sense.
How'd you get 1452?
I'll just multiply 4 times 121 times 3.
Oh, okay, okay, gotcha.
And I left the pi alone just so it's a little prettier. So part B, they just change R. So I'll leave that one to you, I think. Let's see here. Look at the schedule. Where are we at today? Yeah, okay. Yeah, I guess that's it for today. You guys have any homework questions that you're struggling with? That's all for 3.6. I'm gonna let you guys work on the rest.
Um,